Hello everyone, welcome to Automation Community. In this section, we are going to see about logic gates. If you have not subscribed our channel, kindly subscribe our channel for more updates. So, in our previous section, we have seen the remaining logic gates in Triac Programmer. So, in this, we are going to see two. One is XOR, another one is XNOR. Right? So, XOR gate, we have a truth table over here. So, if both the inputs are off, output is off. If any one input is on, output is on. But if both the inputs are on, output have to be in off condition. So, this is a bit complicated comparing to the previous logic gates. So, if both the inputs are off, output is off. So, in our previous gates, what we have come to the conclusion that by seeing the first condition, we will be getting the conclusion like whether we have to use, normally open contact or close contact, whether it is in a series or whether it is in a parallel. But here it is very bit difficult to understand how to put the contact first, whether normally open or normally closed. Correct? So just check it out here. If any one input is on, output is on. So this is something like, OR gate, right? If both are off, output is off. If both are on, output is still in off condition. So with only two contacts, we cannot able to make this logic. But we have only two inputs only, no? So how to get that extra contact? So there is no need to use the extra contact. You can use this input 1 as normally open and also as normally closed. And same in 2 also, you can use in one place, you can make use of that as normally open. In another place, you can use that as normally closed. So you can change the the way of using the inputs, but it will be the same input only. There is no extra contacts, same input only, but different conditions. So let's see that in the programming software. So I'm using 0.00. Okay. So now I'm putting one normally closed contact and naming that as one more input. Okay. So connect and output. So just connect these two. So I'll just go for the simulation as of now. I'll just to explain. Alright. So what it is telling? 0, 0. Output is 0. Have you got the first one? 0, 0. Output is 0. Correct. So let's perform this condition. Third one. 1, 0, 1. So what I'll do? 1, 0, 1. Anna. So I'm going to turn on this. 1, 0, 1. So the third condition is also coming. Correct. So 1, 0, 1. So let's perform the third one. Second one. 0, 1, 1. So let's see that 0, 1. 1 means I'm going to turn on this. So I have turned on this, but output remains off. But my condition have to be 1. So with this, I cannot perform the second condition and fourth condition. So what I have to do means, I have to make one parallel contact. I'll put here and name that as same as this. Understood? So see here, now first input is using as normally open condition and also as normally closed condition. Okay. So put one more normally open contact and name that as 0.01. So see here, this 0.01 is normally closed here but open here. This 0.00 is open here but closed here. I will go for the simulation. So it is not that we have used 4 inputs. See, I have used only 2 inputs, input 1 and input 2, correct? See, all the inputs are off condition, but look at my output, it is turning on. Output is turning on. So output have to be in off condition, right? So there is some mistake over here. So let's see what is that mistake. Okay. Now the input is coming from this location. See output, how output is on? From here and it is going through this location. The route it is taking the rung, the power from positive rail is starting from I 0.0 is normally closed contact and normally closed contact of I 0.01. So my output have to be in off condition, no? So the way of the order of putting the contact is wrong here. So what I have to do, instead of putting this, I'm putting it here. Okay, I'll do one thing. I'll just delete and add it again. I'll cut it. I'll paste it. Okay, we'll add instead of that. I'm putting 0.00 here and 0.01 is here. So now what will happen? Now the path it cannot take. The path it will not take from this location, correct? So let's see that. I'm going for the simulation mode. And now look at this, the output is in off condition. Correct, because the path is closed here. This is on, this is normally closed contact, this is also normally closed contact, but the address is crisscross. This is 0.0 here, normally open, and this is closed. This is open here, this is closed here. If you interchange the order, output will be in on condition, correct? So 0, 0, 0 is done. Now 0, 1 should be 1. 0, 1. That means what? I'm not going to disturb the first input, but I'm going to disturb this input. So look, output is on condition. How output is in on condition? Because I have turned off this, no? I have turned on this. Since I have turned on this has to be on. Why this is turning on? See, I have not turned on this. Is it like that? No. See, this is normally open contact, right? This is normally closed contact. If I disturb this contact will also get disturbed because both are sharing the same address. You want to have a look means I'll do it again. Can you see this is also changing? Okay, let's turn on this. This will change. Understood? This is the working of normally closed contact. So the second condition is done, which is 0, 1 should be 1. 0, 1 should be 1. What is the next one? 1, 0, 1. So I'm just make this to off again. So now what is the condition? 1, 0. So I'm going to disturb the first switch. This one. Disturb this. Output is on because it is taking this route directly. So what is our last condition? 1, 1. So I'm going to turn on both this and this. So turn on, turn on. Output is off. That's it, no? So both are on, output is off. So that's it about XOR gate. Don't confuse why I have used 4 contacts here. I am using only 2 contacts. Address to address, but usage of contacts is different. At one place it is normally open, at one place it is normally closed. So that's it about an XOR gate. I hope you have understood the concept. If you like this video, kindly like and subscribe our YouTube channel for more updates. I'll meet you in the next session. Until then, bye.